Welcome to part 2 of the Gas series. In part 1, we set up our base character that has the ability system component on it, and we created our player and enemy blueprints from that character. In this part, we're going to build our first ability, the Dash. You will learn what gameplay abilities are and how they're activated, and you will learn what gameplay cues and gameplay tags are and how to use them. So let's answer the question, how exactly does the Dash ability work within our gameplay ability system? Well, there are 4 core building blocks of Gas that we are going to use in this ability and almost every other ability as well. These 4 building blocks are gameplay abilities, gameplay cues, gameplay effects, and gameplay attributes. Now, let's see what role each one of these plays in our Dash ability. First, the game starts and the player is given a gameplay ability class through the ability system component that we set up in part 1. Then the player presses a button that triggers the gameplay ability to activate. Now we get to our first core component, the gameplay ability itself, which is the class responsible for moving the player forward a certain amount. Alright, and what about all these flashy effects and sounds that appear? Well, these are the responsibility of our second building block, the gameplay cue. As soon as the ability is activated, a gameplay cue is added to the player, which spawns the particle effects, hides the mesh, and plays a sound. Then when the ability ends, gameplay cue is removed, which shows the mesh again, spawns a different sound and effect. Awesome, we've discussed abilities and cues, but what are effects and attributes? Well, the gameplay attribute in this case is stamina, which is the cost of our Dash ability. And gameplay effects are what modify these attributes. So, when the gameplay ability is activated, it applies a gameplay effect responsible for deducting a certain amount from the gameplay attribute called stamina. Finally, a second gameplay effect responsible for setting the cooldown is applied as well. So there you have it. The gameplay ability holds the logic of the ability itself, the functionality. Gameplay cues are responsible for the visual part of the ability. The gameplay effects are responsible for stamina costs and cooldowns, and stamina itself is the gameplay attribute. Now we know how to create our Dash ability within the gameplay ability system framework, so let's start building. Now that we set up the gameplay ability system component in part 1, let's make sure that it's actually working. So let's do that by giving the player a dummy ability and then activating that ability. So let's see how that works. So generally, what you would do is you would get your ability system component and you would call the function give ability. And then you can give ability by selecting the class of the ability, but we haven't created any ability yet. These are just default abilities that come with the template. So let's create our first dummy ability. So I'm going to go here to my content folder, gameplay abilities, and I created an abilities folder here. And in it, I'm going to create a new blueprint class. And I'm going to open all classes and search for gameplay ability. So this is the one we want, just gameplay ability. And I'm going to call it GA for gameplay ability underscore test ability. So it's just a dummy test ability. And then over here now, I can see my GA test ability. And let's do this on begin play. So begin play, we'll just give our character a dummy ability. So when you open up an ability blueprint, this is what we'll see. I'm going to explain everything in a second, but for now, let's just test that it's working by adding a print here. So on activate ability, I'm just going to say print ability activated. And when the ability ends here on end ability, I'm going to print ability ended. And after printing, I'm going to call end ability manually to end the ability. So it's an ability that does nothing. It just prints activated and then ends and then prints ended. And in our player here, we've already given the player this ability. You have to give characters abilities before they can use them. So if you try to use an ability that you haven't given to a character, it won't work. So let's try to use this ability for now. So I'm just going to do like Q on the keyboard, just as a test now. So when I press Q on the keyboard, I want to activate this ability. So activating abilities, you do it by getting your ability system component and then calling try activate ability. And you can activate abilities through multiple ways. Right now, let's just use the default, well, not the default. Let's use try activate ability by class and make sure that it's working. I'll explain the different activations in a second. And let's choose our test ability. So right now, if I play and I press Q, it prints ability activated and ability ended. Excellent. So the gameplay ability system is working. Now let's delete all of this dummy code that we've written and also delete our test ability, and time to create our actual first ability, which is the dash ability. So back in my abilities folder here, so right here, I'm going to create a new blueprint class. Again, gameplay ability, just like we did for the test, and call it GA dash. Oh, it's not in my abilities folder. Whoops. Oh, it is in my abilities folder. Never mind. So let's open it up, and now let me explain some of the things that you will notice when you first open an ability. So I showed you the activate ability. It's when the ability is activated, this is what happens, and when the ability ends, this is what happens. There's also a few more functions you can override, like if an ability activates from an event, whether the ability can be activated or not, and so on, but we will be discussing all of these later. Right now, the most important thing I want to explain is under the class defaults, tags here. Every ability has a lot of tags that are associated with it, either tags that it has or tags that it can give. If you don't know what tags are basically hierarchical labels that you can attach to actors. So for example, you can have a tag that says the character is on fire, or the tag that this ability is on cooldown. So these are basically pieces of information that you add to your actors. So the tag that we're interested in here right now is this default ability tag. So this basically is the name of this ability. So every ability will have a unique tag for it. So for example, you can go here and you'll find some tags already created by the engine. We're not going to be using that. And we're going to be creating our first ability tag. So we're going to click on this plus icon here and create a new name. So you see the name is x.y.z. When you add a dot, you create a child, or you go down one level in the hierarchy. So we're going to create a new tag called gameplay ability dot movement dot dash. So we're creating a movement category and then putting the dash inside it. This is really important because later on you can do things like filter on all the movement abilities or activate a random movement ability. So it will choose between like dash, sprint, teleport, whatever. And then just under sources, click this default gameplay tags. Now that I added the tag, I can select it here. I see gameplay ability dot movement dot dash. Now this is my name for this ability. Now if I go back to my player, I told you that when you activate an ability, so you get your ability system component and you say try activate ability, we did activate ability by class. But there is also try activate ability by tag. So I can just say activate the ability, so I can pull off the tag container here and say make. And then say activate the ability with the tag movement.dash. Or I can say activate the ability with the tag just movement. And then it will pick randomly one of the dash or other movement abilities I may have. So we're going to be doing a lot with tags later on, but I just wanted to give you a brief overview of what they are now. So back here, there are a lot of other tags, like, for example, a tag that is required for the ability to be activated, but we're not going to be going over all of them in this tutorial, but we will be going over most of them later on. Now, the next thing I want to discuss, which is also really important, is the replication policy. So all gameplay abilities can either be replicated or not replicated. You don't always want to replicate them, even though we're doing multiplayer. For example, this dash ability won't be replicated, because it just moves the player, and movement itself is replicated by the character movement component. So we don't need to replicate the ability itself. The ability can just trigger movement, and then movement actions will be replicated. Now, the next thing is instancing policy. This is also very important. There is instance per execution, instance per actor, or not instanced at all. Instance per execution means every time you activate an ability, a separate instance will be created. But instance per actor, that means that each actor has a unique single instance of this ability, and each time it's activated, the instance will be reused. Why is this important? Well, for example, if I create a variable here in my ability and call it like activation or used count, something like that. So how many times this ability was used. So every time I use this ability, I can then take this used count and increment it, which means add 1 to it. Now, if this is instance per actor, this variable will persist. So there's only one copy of this ability for this actor. So every time the actor activates it, this used count will go up by 1. So I activate it 5 times, this number will be 5. But if it's instance per execution, this number will always be the default, which is 0. Because every time we we activate the ability, we create a new instance of the whole class, which means we create fresh variables. Most of the time, we're going to be wanting to use abilities that are instance per actor and not instance per execution. So we're going to change this instance per actor. And by the way, for replication as well, only instance per actor can be replicated. Now, there's a lot more here that we can discuss. For example, there are the costs. These are effects that say how much this ability costs. For example, dash can cost 25 stamina. And cooldowns, how long is the cooldown? This is also a gameplay effect. So both costs and cooldowns are gameplay effects, but we're not going to discuss gameplay effects just yet. But it's good to know that this is something supported by abilities as well. So let's delete this fake variable. And now let's start implementing the functionality of our dash. So the dash will basically move my character quickly from one location to another over a set period of time. Now, the very, very nice thing about the gameplay ability system is that it comes with a bunch of tasks. So I'm going to search here for tasks. Tasks are pre-made latent functions that are going to be useful in most of the abilities you make. Latent function, it just means that it's a function that does something and then finishes later. So it does something over time. And you have a lot of these tasks. You have a lot of wait tasks, but you also have a lot of root motion tasks. So these are very useful. So apply jump force, apply move to force, and so on. The one that we're interested in for this specific dash is apply root motion constant force. This basically applies root motion in a specific direction and given a specific strength and duration. And then it tells you when it finishes, so when the character reaches that location or when the duration is over. So this is very useful because we don't have to handle things like collision, dashing through walls, any of that, because this literally moves the root component of the character, and therefore all of that is handled by default. So these tasks are very handy, and we are going to be creating our own custom tasks again in later parts when we get into the more advanced stuff a bit. So let's just test that this works now. I'm just going to dash in the forward vector of my character. But be aware, right now we are in an ability. So you can't say get actor location or something because this is not an actor. And you don't have really an owner like you would do from a actor component. So how do you get a reference to the character within an ability? The function is named a bit weirdly, but it's get avatar actor from actor info. This function will be calling all the time because this is how you get the character that is running this ability, or the character that this ability belongs to. So this is basically right now my Nexus player character if I'm calling dash from my Nexus player. So then I can get the actor forward vector here, and that will be my direction. And then strength, let's put something like, I think 2000, and duration, a very short duration, like 0.3 seconds. All right, that's it for now. Oh, and on finish, it's very important to call end ability. Now, end ability is one of the most important things that people forget to call, and then the ability just gets stuck. So you have to always call end ability on all of your execution pins. So make sure that an ability is never started without being ended, otherwise it gets stuck. All right, so now we have this ability that just dashes in the forward vector. let's test it out, see how it works. So in my begin play here, I'm actually going to create a separate function. This is in my player character. I'm going to create a separate function, call it give abilities, just to organize things a bit. And then get my ability system component and say give ability and search for my dash. And later on, we're going to be doing complex things with abilities. We're going to have like each weapon has its own ability sets that are added or removed when the weapon is equipped and things like that. But for now, let's start simple. And then on begin play, we just call give abilities. And let's also do the same thing. Keyboard, I don't know, left shift. When we press the left shift button, we're going to try and activate ability by class. And the ability we're going to try to activate is our dash. And let's test it out. So I'm going to play, press Q. Nothing is happening. Oh, I'm pressing Q, not left shift, sorry. Press left shift. There we go. There's a dash. So it seems to be working. But there are a lot of things we need to improve about this dash. For example, if I dash in the air, I can almost dash very far versus dashing on the floor. So we need to do some things. And if I'm going left and I want to suddenly dash right, I can't do that. I have to wait till I completely turn to dash in the direction I'm turning. So we're going to fix a few things, and along the way, you're going to learn a bit more about the ability system. So let's start here by getting the direction. I don't want the direction of my dash to be the direction, the forward vector of the actor. I want it to be the last movement input the actor pressed. So if I'm moving forward and then I press back and dash, I want to dash backwards right away without having to wait for the character to turn. So I'm going to create another function here just to, again, make things clean. And we're going to say it get dash direction. Okay, and it just returns an output here, which is a direction vector. So the way we're going to do it is we're going to call, again, this weird function, get avatar actor from actor info to get my character. And then I'm going to cast it to a pawn. And I'll show you why in a second. So I'm going to cast it to a pawn because the pawn has a get last movement input vector. So wherever the last movement input was on the keyboard, or if it's an AI controller, wherever the AI is trying to move to, this will be the direction. So I kind of want to always return that, but this might not always be a valid vector. So for example, if I'm not pressing anything or if I'm standing still, this is not valid. So we need to first check, do a branch if this number is 0. So if this vector is 0, then we want to return something else. We want to return, then fall back to the forward vector. So get the avatar actor info and get actor forward vector. All right. And then if it's false, so it's not 0, then we return this value. And also if the cast fails, so if you try to call dash on something that's not a pawn, then also have it return the forward vector of that thing. So it also supports things that aren't pawns, but if it is a pawn, then it uses its last movement input vector if it's not 0. And then we're just going to use that here, get direction, dash direction. Oh, and we can also make the function a pure function because we don't need any execution pins. So then pure function would look like this. Excellent. So now let's see what it looks like. So if I'm moving forward and I press back, then I dash backwards. If I'm moving left and I press right and dash, oh, sorry. If I'm moving left and I press right and dash, perfect. So it dashes in the direction of my last input vector. Now we need to handle the dash in the air, keeps going. That's because when the dash is over, there is no ground friction to stop us. So we keep moving forward. That's why this apply root motion constant force gives us a very handy velocity on finish mode. So the velocity on finish by default is set to maintain its last root motion velocity. But that's not good. When you dash, you want to stop moving at the speed of the dash and then move at your normal speed. So I'm going to use clamp velocity. So when you finish dashing, always stop your velocity at a certain number. This should be the max velocity that, the max movement speed the character has. So right now this is 500. Now if I dash in the air, great. It dashes and then stops. Dashes and then stops. Perfect. But this number 500, I don't want it to be hard-coded. Again, this is going to be a reusable ability. So we're going to create a function here called getMaxSpeed that also gets our avatar actor casts to a pawn as well. Because from the pawn, we are going to get the movement component, and the movement component has max speed. Great. And we are going to return this max speed. And let's call it max speed. Now, if the cast fails, so it's not a pawn, just return, I don't know, some random number, the default value. Also make it a pure function. This can be pure. And over here, we can get our max speed. Amazing. So this ability works, but it doesn't look like an ability. So we added the functionality, but we have no visual or sound effects. And that's the coolest part of the dash that actually makes it look like a dash. So let's see how visual and sound effects work within the gameplay ability system. So in the gameplay ability system, visual effects and sound effects and any feedback based on player action usually is done through what's called gameplay cues. So we have now our abilities. I'm going to create a new folder here, and I'm going to call it cues. And let me show you what a gameplay cue looks like. So I'm going to right-click, blueprint class, and search for gameplay cue. Now, there are two types of cues that are important. There's an actor cue and a static cue. And within the static cue, there is a burst cue. Now, I'm going to quickly go over these three types, the static, the burst, and the actor, and explain the difference. So if I create a static cue here and open it up, you'll see it's not an actor, so there's no components tab on the left, and the class defaults don't have much. They only have a gameplay cue tag. Now, again, here is where tags come into play. Gameplay cues need to have a single tag associated with them. What is the name of this cue, or when is this cue activated? So if I try to open this up, you'll see that it doesn't have all of the tags like we had here in the dash. We had a list of all of the tags. But here, it only shows me everything that's under gameplay cue. That's because all gameplay cues need to start with the name gameplay cue dot something. So for example, in our dash, we're going to add a tag called gameplay cue dot dash dot active, for example, and then we put it here. And then we select it. This would be our name for this gameplay cue. Now, right now, the gameplay cue doesn't do anything, but you have a function to override here, handle gameplay cue, that has an event type. And if we switch on it, you'll see what happens when the gameplay cue is activated, while it's active, when it's executed or removed. Now, before we go into all these details, let me show you the difference between other types. Now, you would use this static gameplay cue when you want something to happen once, so like a burst effect, like a hit effect, for example. You want something to happen once and then just stop. So no actor is actually spawned in the level. But for the other gameplay cue type, so gameplay cue actor, now if I open this up, you'll see that this is an actual actor. So it has components and it has a whole bunch of things on the left here associated with the gameplay cue is override, allow multiple, but of course it has the tag as well. Now, you'd use actor when you want to create something that persists. So for example, the player activates a shield and then the shield creates a bubble around them. Now, this bubble would be an actor that's spawned in the world, and you would use an actor gameplay cue. Now, one more thing is I told you there's another type, so I'm just going to go here to my static. This is the static gameplay cue, and I'm going to change its class from static to gameplay cue burst. Now, burst is a child of static, but as soon as I do that, you'll see that the class defaults here have now filled with a whole bunch of things. Now, burst, you'd use this for burst effects, and this is just a gameplay queue static notify that has a data asset associated with it. So you can easily spawn things like particle effects, just add them here. Sounds, just add them here. Camera shake, choose your camera shake here. Lens effect, forced feedback. So anything you want to do once, you can find an option for it here. And we'll most of the time be using this for like impact effects, camera shakes, feedback, and so on. But for the dash, I'm going to be creating a simple static, not a burst gameplay queue, because I also want to hide the mesh of the character when they're dashing. And you can't do that through these options. So I'm going to have to build my own functionality. Of course, if you use these options, so if I play a sound here, for example, I don't have to override any functions or write any logic myself. This will automatically be done when the gameplay queue is executed. All right, and that's what you need to know about gameplay queues for now. Let's delete all these dummy queues that we've created, and let's create our actual gameplay queue now. It deleted my folder, lovely. Let's create my queues folder again, and let's create a blueprint of type gameplay queue notify static. And we're going to call this our GC for gameplay queue dash. And open it up. It still has my dash tag, lovely. So we don't need to add that again. But we do need to override our handle gameplay queue function. Now here, this is very important. These are all the things that happens during a gameplay queue's lifetime. So I'm going to switch on them and see. What I'm interested in is activated and removed. I'm going to talk about the difference between activate and execute in a second, but now what I'm interested in is only when the gameplay queue is activated, so the dash is active, and removed when the dash ends. We're going to spawn some sound, some particle effects, hide the mesh, and make it look like a proper dash. So the first thing I want to do here is actually get my target and cast to a character, because we need a mesh, so we need to be a character. And I'm going to promote this to a local variable. Local just means it's inside this function only. And I'm going to call it my character ref. And don't worry about if the cast fails. We're going to be handling that later. And then on activate, what I want to do is I actually want to spawn a particle effect that I have here. So I added this effect. I don't remember where I got it from, probably one of the Paragon assets, but I modified it to make it yellow. And I have a whole bunch of these custom effects, and they're all available to download on Patreon with the project files. But here on activate, I'm just going to spawn a particle attached. And it's going to be this teleport particle that I just showed you. And I'm going to attach it to the target's root component. So my target here, I'm going to get the root component and attach this particle to it. And then what I also want to do is get my character ref. So just convert it to a validated get. So I just right click, convert to validated get to make sure that it is valid before getting its mesh. And then after getting its mesh, I'm going to set its visibility to false, so not visible, and propagate to children. So anything that they're holding as well, any children actors or meshes are also not visible. And ignore this return node for now. We're going to do this at the very end. Actually, you can just do this return node here. So here, do a sequence. Do all of this. And then after the sequence is done, return. All right, so this is when the dash is activated. We are going to spawn a particle effect and hide the mesh. Then next up, when it's removed, I want to spawn a separate particle system. So spawn particle at location this time. We're not going to attach it. But I'm going to spawn this explosion effect. And this is just the starter content explosion effect that I made yellow as well. So I'm spawning this explosion effect at the location of this actor. So get my target again, get the actor location, and that will be this location. And then I want to do this as well. So get my character and unhide them. So make the new visibility visible this time. And that's pretty much it. Oh, I almost forgot the sounds. So before actually hiding the mesh and checking if it's valid, let's play a sound. So let's do play sound at location. So I have, again, this teleport sound, sounds like this. And I'm gonna play it at this root component's get world location. And then when the teleport ends, let's also play a sound. I'm just gonna copy this node. There's also the sound that comes with the engine. It was called floating UI open, something, one of these. Yeah, one of them. So it just gives more life to our ability. Oh, and this particle effect, this teleport one is very large, so I'm going to scale it down to like 0.3. All right, so now we have the gameplay queue. The gameplay queue itself isn't being used right now. So how do we use a gameplay queue? Well, there are multiple different ways to use a gameplay queue, but in our use case, we are going to use it by adding it manually within the ability itself. So just after we do apply root motion, so on this pin, there is a function. So if we search for gameplay queue now, you'll see there is a lot of gameplay queue functions. The one we're interested in is add gameplay queue to owner. Now, there is add gameplay queue to owner and execute gameplay queue on owner. What's the difference between adding a queue and executing a queue? Well, that's a very important distinction, and which brings us back to this on activate and on execute. So when you add a queue to the owner, you add the gameplay queue and the tag will remain on the owner until removed, which means that you can add dash is active, and when dash is over, remove the dash is active. Therefore, on active will be triggered and on removed will be triggered. But when you execute a queue, it's not added to the actor. It's just executed once. That means on execute will be triggered, but on active won't, and on remove won't. So you do add when you want the queue to remain on the actor for a while, and you want to do something when it's removed. You do execute when you just want to fire a queue once and you don't care what happens later. So in our case, we want to add the queue because we do care what happens when it's not there anymore. So just add the queue and search for our dash active. And it has this really handy pin remove on ability end. So when you call end ability, this queue is automatically removed, and then the removed pin will be triggered, and we don't really have to handle that ourselves, which is great. All right, so now let's test it out, see if this is working. If I play and I dash, woo, nice. Now that's a dash. Now let's do I'm just going to do some slow motion debugging. So do the tab debug key. And when we press tab, we set global time dilation to 0.1. And when we release it, we set it back to 1. Now I'm just doing some debugging in slow motion to show it to you in slow motion. So right now I'm moving and I press shift, spawn an effect, attach it to the player. Player is finished dashing, the effect is removed or the tag is removed, and another particle is spawned. So this is an example of how gameplay queues and gameplay abilities work together. Now, gameplay queues aren't only triggered like this, there are multiple ways for a queue to be triggered, and we're going to discuss a lot of them moving forward. But for now, this is basically our dash ability. You have now just learned how gameplay abilities are activated, how they work together with gameplay queues, and what gameplay tags are. But in the beginning, we also discussed gameplay attributes and gameplay effects. These will be the topics for next lesson, where we discuss how to create stamina for the character and how to add a cost of the dash, which costs 20 stamina, for example. Now, you may notice that I'm using some pre-made assets for these tutorials, like the UI widgets that I'll be using and some visual and sound effects. Now, these are all available to download on my Patreon, but you don't really need them to follow along. But if you do want something that looks cool and you want to support me as well, then I spend a lot of time crafting and customizing these things just for you. So check it out and you'll be helping out the channel a lot. And if you like this part, make sure to like and subscribe and hit the bell icon to be notified when part 3 comes out. And if you're a Patreon member, part 3 will be releasing early for you. So as always, thank you for watching and I'll see you in the next one.